Welcome everyone to the third video coding the wall art VisionPro app from scratch. Last time we implemented the canvas on the wall and the character floating in space. And in this video I want to implement the behavior that when you tap on the character, we see some UI with the contents of what the character is saying and then presenting a button group to allow the user to interact with the UI and confirm that they want to keep going in the flow. And so the technologies that we're looking at in this video are SwiftUI attachments, which will allow us to display SwiftUI content inside 3D content. And we're also going to work with combine and implementing animations on the character to perform the wave animation. And so in order to do that, let's head back to XCode. And the first thing I want to do is go to our reality view down here. And in order to implement SwiftUI attachments that don't live in a window group, but instead live alongside our 3D content, we can add a new closure to our reality view called attachments. And when we do that, we also need to add a new parameter here, which we can also call attachments, in the body closure. And once we've done that, we can implement the attachments closure. And what I'm going to do here initially is just implement a VStack, which contains a text field, and it'll take an input text, and it'll just set some parameters on it, and then add a tag called attachment, and it'll have an opacity, which will be 1 if this property show text field is true, and 0 otherwise. And so we haven't actually implemented these two variables, input text and show text field. So let's do that right now. And let's just go to the top of the file, and we can implement these two variables. The input text is just a string, and the show text field is a Boolean. And the way this is going to work is that in the reality view body closure, we can retrieve our attachments content and attach it to the actual content. So the way we actually implement that is as follows. We can go and call attachments.entity for attachment. And this ID attachment corresponds to the tag that we set down here. And once we have this attachment entity, we can set the position of it, and we want to rotate it just like we rotated the character. And watch the previous video if you want to understand how that's being done. And then what we can do is we can attach the attachment to the character by calling characterEntity.addChild attachment entity. And yeah, that's basically all we need to do in order to add the SwiftUI code into the 3D environment. And so let's now actually work on implementing the behavior that when we tap on the character, we want to show it. Because remember that the opacity of the character is 0 if the show text field variable is set to false, and we initialize it to be false. So if we were to run it right now, we shouldn't be able to see the attachment. So let's actually now also add in a reference to the view model in our immersive view. And in order to grab the view model instance from the environment, we need to pass it into this view when we initialize it. So just like we did here in the wall art abstract with the content view, we now need to also pass in the view model as an environment object to the immersive view. And when we do that, we can simply have access to the view model as such. And now what I want to do is I want to actually implement the tap gesture. So we can go down here to the reality view. And what I want to do is on the down here, I want to say I want to add a gesture modifier. And this gesture modifier will be a spatial tap gesture, and we will target it to any entity. And when we get a callback with this gesture, we just want to set the flow state property in the view model to intro. Remember that if we go to the view model, the only parameter it contains is this flow state parameter right here, and it basically contains our state in the sequence. And so the states are idle, intro, projectile flying, and update wall art. And so initially it's idle, and when we get the call for the tap gesture, we want to set the flow state to intro. And that should trigger the appearance of our SwiftUI attachment and should show some text that gets animated in. And so in order to do that, let's implement another view modifier on the reality view. And this time it's an onChange modifier. And this onChange modifier will listen to the state in the view model. And when a state change occurs, we want to get that callback right here. And the callback of the flow state is of type flow state. And we can have access to the new value, which gets passed in. And then we can just implement a switch statement to handle each case. And right now, nothing happens. But what we want to happen is that we want to add some logic to the intro case, because when the spatial tap gesture changes the flow state to intro right here, we want to perform some logic down here. And so we want to implement a function called play intro sequence. And this function should be called in the onChange modifier. And this function will be responsible for changing the text in the text field property and animating certain changes to our UI. And so let's begin by adding in some initial piece of logic. So we can add a task inside this function, and this task will be responsible for performing all our logic. And the reason I'm wrapping it in a task is because we're going to do some asynchronous work, and so this is not an asynchronous function, which is the reason we need a task which wraps this work. And so the first thing we want to do is, if the show text field property is false, then we want to animate the change of setting that property to true. And by wrapping it in a with animation, SwiftUI will be able to animate the SwiftUI attachment into sight. And so we can actually try this out right now by running this. And once we run it, we should see that when we tap on the character, we get a sort of SwiftUI attachment popping up right here. But compared to the final result, we don't have any text showing up yet, nor do we have these buttons being shown down here. So let's move on to actually implement that now. Actually, before we do that, let's also implement the wave animation of the character when we initially tap on it. And in order to do that, we can go below the if show text field code, and we can add in this bit of code right here, which calls assistant.playAnimation wave animation with a repeat count of 1. And we haven't defined the assistant and the wave animation yet, so let's do that. The first thing we want to do is just create some state up here, and we want to have an assistant entity or a reference to the assistant entity, and we want to have a reference to the wave animation. And so these are optional, and so we need to actually set these in our reality view body. So let's do that, and we can do this by implementing the following code. All right, this is what I just added, and let's go through it. The first thing we're going to do is look for an entity named character animations in our RealityKit content bundle. And if we remember, or we can just double check by going back to the Reality Composer Pro project, we have this character animations.usda file down here. And that's what we're referencing right here. And then we're creating a new variable called wave model, and it's going to look for a entity called wave model on the character animation scene entity. And you can see that the wave model is defined right here, and we can even play it inside Reality Composer Pro. And so we now have this wave model. And we can also look for the character called assistant on our initial character entity. And this corresponds to this assistant in our immersive scene right here. And so now that we have those, we can then set our global variables self.assistant to the assistant and self.waveAnimation to wave animation. And the way we get the wave animation is by creating a wave animation by calling try animation resource.sequence with wave animation resource and idle animation resource repeat. And the way we get those two resources is by calling assistant.avalableanimations.first, because the first animation on the assistant in the immersive scene is the idle animation, and the first available animation on our wave model is the wave animation resource. And so that's how we basically initialize them to be ready for us to work with in code. And so now that we've done that, we can head back down to our function play intro sequence. And if we actually run this now, we should be able to animate the character with the wave when we tap on it. And so that worked. And so that's nice. So let's move on to actually implementing the SwiftUI attachments UI further. And in order to do that, let's go below here and add in, let's implement this new function called animate prompt text. And what this function is going to be responsible for is animating in the text in the UI the way we had it in the final project. And so it's very simple, actually. It's going to take a text parameter as its input, and then it's going to just take each word and append each word to the input text variable, which is the one that drives the content of our text field in the attachment. And so we just implement a little delay right here, and so that's where the animation comes from. And so we can now make use of this function by calling animate prompt text, and we're going to grab the first string in our texts array, which is, hey, let's create some doodle art with the VisionPro. Are you ready? And so let's run this now and see what that actually looks like. We've now implemented the wave animation, and we've implemented the showing of the SwiftUI attachments and the displaying of the first text. And so all that stuff works. We have the wave animation and we have our text showing up the way we expect. So now what we can do is we can basically implement the button group down here. And the question is, essentially what we need to do is we need to hang out and we need to wait until the user performs an action. So we need to just listen to that action. And one of the best way to implement that is using combine. So the first thing I'm going to do is just import the combine framework. And I'm also then going to implement some additional state. And what I'm going to implement here is a show attachments button, which is going to be responsible for either showing or hiding the buttons. And then I'm going to create a pass-through subject, which will be responsible for passing along information regarding the user pressing the button. And I'm also going to require any cancelable object so that we can cancel any outstanding listeners. Now, once we've done that, we can go back to our function play intro sequence, and down here I want to implement the animation which will show our buttons. And so I want to show these buttons, but we haven't actually implemented the SwiftUI code for that yet. And so what we want to do is go back to our attachments closure on the reality view. And in our VStack, we don't want to just display this text, but we also want to display the buttons. And so what we can do here is we can say, if attachment buttons is true, we want to create an H stack which contains two buttons. And the first button is just has the text yes, let's go. And the second button has the text no. And when the first button, yes, let's go, gets tapped, we want to send a message to our tap subject. And then as a result of that message being sent, we want to perform an action. And you can see that we also set the opacity down here based on the state of the show attachments button variable. But now this is kind of the important bit right here, tap subject.send. So now we actually need to listen to that event happening. And in order to listen to this event happening, let's implement a new function, and we can call this function wait for button tap using a button tap publisher, which is of type pass-through subject, which is the one we created earlier. And then in this function, we can call await with checked continuation. And inside this continuation, we essentially call tabSubject.first.sync. And when a callback gets received here, we can call continuation.resume. And so the way you have to think about it is that at a high level, this function just blocks until an event occurs, until the user presses yes, let's go. We call this function, and this await with check continuation will block right here until we call continuation.resume. And continuation.resume will only be called if we get a message from the tab subject. And the only place we're sending a message to the tab subject is in the action closure of the button. And so the order of events here is the tab subject sends a message, we receive a callback in the sync closure on the tab subject, which then in turn will call continuation.resume, which will then return from the with checked continuation closure, and we will return from wait for button tap. And so if that's confusing to you, I would encourage you to look into the combine framework, but that's what's going on at a high level here. And so once we've done that, we can simply go back to our play intro sequence method, and we can call await wait for button tap using our tap subject, which is the one we instantiated above here. And so let's scroll back down, and we're waiting for the button tap, and then once the button has been tapped, we will hide the buttons by setting the show attachment buttons property to false. And then we want to animate the prompt text and use the second element in the texts array. So it'll say, awesome, draw something and watch it come alive. So let's build all this right now and see what that looks like. So we have the poster on the wall and we have our character, and let's move that out of the way and let's tap on the character now. We should see the wave animation, we should see the text animating in, and we should see the button group appear. Okay, amazing. We can tap yes, let's go, and we would expect the text to change and the buttons to disappear. Okay, amazing. So all of that worked. We're now animating in some text onto the character, which is using SwiftUI attachments in a reality view. And we're using combine in order to pass some state around and make sure that we're waiting for the user to actually perform an action. And I want to leave it here for this video. And in the next video, we'll implement the Doodle canvas in order to actually let the user draw. So that'll entail creating a window group and working with some UIKit content inside of visionOS as well. So I'll see you then. Bye-bye.